Hello friends, I welcome you in lecture number 15 on hypothesis testing. In this lecture, we are going to discuss about large sample test for single proportion or one sample Z test for a population proportion. If you are familiar with this sampling distribution of sample proportion, then we can understand this lecture. If you have not seen my lectures on sampling distribution of sample proportion, which are lecture number 5 and 6 on sampling distributions, then I suggest you to watch those two lectures first and then go for this lecture so that you can understand whatever we are going to discuss in this hypothesis test for population proportion. And if you have seen those two lectures, then you might be familiar that what we mean by sampling distribution of sample proportion. So just we recall that idea of sampling distribution of sample proportion. Suppose we have some population and suppose we are interested in some characteristic of that population, and suppose small p is the proportion of that population with that specific characteristic. Now suppose we want to check the hypothesis that population proportion is equal to some constant, say p0. Then for that we consider a random sample of size n from this population, and suppose the number of elements or observations in that sample with that particular characteristic of interest are, say, capital X. Then the sample proportion is denoted by p hat and is given by p hat equal to x divided by n. And if this condition is satisfied, that is number of observations in the sample time population proportion and n times 1 minus population proportion, if these two quantities are greater than 5, then we have discussed in lecture number 5 on sampling distribution that in that case this sample proportion is following normal distribution, and if we standardize it, this sample proportion is a random variable which is approximately a normal random variable, and the mean of this sample proportion is equal to population proportion, and standard deviation is given by square root of p times 1 minus p divided by n. And if we have this condition satisfied, then we can say that if we find out this random variable capital Z, which is standardization of this sample proportion. To standardize a normal random variable, we are subtracting a mean of that random variable and we are dividing by standard deviation of that random variable. So if we consider this, then we have p hat minus small p, which is mean of sample proportion, and standard deviation is square root of p times 1 minus p divided by n. So this is approximately a standard normal random variable. So this is going to be a test statistic for hypothesis testing about population proportion. We will remember this: Z equal to p hat minus small p divided by square root of p times 1 minus p divided by n. This is the test statistic for testing the null hypothesis that population proportion is equal to some hypothesized value. So remember this formula for test statistic about test statistic for hypothesis testing about for population proportion. So that I have written here. Suppose capital X be the number of observations in a random sample of size n that belongs to the class associated with this population proportion P, then if the null hypothesis is true and n times P and n times 1 minus P are greater than 5, then the test statistic is Z equal to P hat minus population proportion divided by square root of population proportion times 1 minus population proportion divided by n, and this is approximately a standard normal random variable. And these are the critical regions for testing this null hypothesis P equal to P0. We are familiar with the procedure of hypothesis testing. So if you recall, first we specify null hypothesis and alternative hypothesis. If null hypothesis is small p equal to P0, then there are three different alternative hypotheses. If we have P less than P0, then it is called left-tailed test. If P is greater than P0, it is called right-tailed test, and this is called two-sided alternative hypothesis. And because our test statistic is approximately a standard normal random variable, we have sampling distribution of sample proportion is having the shape of normal distribution. So we are familiar with standard normal distribution. This is the sampling distribution of sample proportion, and here this is not p hat, these are the values of test statistic Z, which is given by this formula. So we consider this standard normal random variable, this is the center, and suppose we have this alternative hypothesis P is greater than P0, and suppose we consider level of significance as alpha, then this point will be Z alpha, and area to the right side of Z alpha is alpha. So if our calculated value of test statistic is to the right of this critical value of Z, then we reject null hypothesis in this case. Similarly, if we have left-tailed test, then here we will have minus Z alpha. So in that case, we reject null hypothesis if Z is smaller than minus Z alpha. And in the case of two-tailed alternative hypothesis, we divide this area into two equal areas alpha by 2. So this point is minus Z alpha by 2, this point is Z alpha by 2, and these two regions are rejection regions. So here if Z is to the right side of Z alpha by 2, or if Z is to the left side of minus Z alpha by 2, then we reject the null hypothesis. So the process for hypothesis testing is similar to the process for hypothesis testing about population mean. If you recall, if we have the hypothesis testing for population mean, say mu equal to mu0, and if we have large sample, then the formula for test statistic was x bar minus mu divided by sigma over square root of n. This mu is nothing but mean of this sampling distribution of x bar, and this quantity is nothing but standard deviation of this x bar, sigma over square root of n. So same pattern here also we have, but instead of population mean, now we are trying to consider population proportion. So our null hypothesis is population proportion equal to some fixed constant, say P0, and here also our test statistic is standard normal random variable, instead of sample statistic x bar, here we have sample statistic as sample proportion minus mean of sample proportion, which is small p, divided by standard deviation of sample proportion, which is p times 1 minus p divided by n. So the only difference is in the formula of test statistic, otherwise remaining procedure is exactly same which we have followed up to this lecture on hypothesis testing. And here we remember that this sample proportion is given by capital X by n, where capital X is the number of elements having that specific characteristic from that sample of size n. Small p is population proportion. So you should keep this formula in your mind, and in the next lecture we will discuss some problems on the hypothesis testing for single proportion. So this is all about this session. I hope you like it. Thanks for